Did you know Neptune is the only planet in our solar system that's invisible to the naked human eye? It's a complete mystery. Scientists can't see inside it, so how do they know about its interior composition? That's not all. So put your crystals down and pick up a pen and paper, as I'm going to tell you everything about everybody's favourite planet. We all learned about the 8 planets in our solar system in elementary school, but we don't get to know about what life is like on these planets, and how their existence affects life on Earth. We have yet to learn about orbital stability, the number of moons, the chances or the sustainability of life on them. But by the end of this video, you'll know. I'll also share how Neptune's existence was proven. So buckle up and sit tight for a round trip to Neptune. So, it's the furthest planet from the Sun and the 4th largest. But did you know it's considered the bluest planet? Even more blue than the Earth. Scientists have nicknamed Neptune the ice giant, or giant blue. For comparison, Earth looks primarily blue from outer space, but Neptune is straight up cobalt blue in colour. This vibrant azure colour is because of the thick mixed soup of water, hydrogen sulfide gases and methane gases in its atmosphere. Not only that, but the mantle surface of this majestic planet is icy water and ammonia, both adding to the most fantastic amalgam of all hazes of blue. This majestic blueness is surrounded by the most interesting celestial phenomenon. All 4 giants of the solar system have rings around them. Neptune has 5 faint rings around it, all of thickness and size. Have you heard about the discovery that Voyager 2, the only spacecraft to visit Neptune, made? In 1989, it observed 4 ring arcs around the planet. Ring arcs are incomplete rings around the planet, usually made of space dust and small rocks, but due to the Keplerian motion, the phenomenon of all planets orbiting the Sun, these faint ring arcs can form and scatter with time. Here's the fun fact. Narrow arcs and clumps of Neptune's rings are thought to be maintained by the gravitational influence of its moons, instead of by the planet itself, especially the moon Galatea. Neptune has 16 known moons. Since moons are natural satellites, they move. Moons orbiting Neptune are no different. Not only in the orbit around the parent planet, but also closer to or farther away from the planet. But what makes it unique is that 2 moons, Hippocamp and Proteus, are slowly moving away from Neptune, while Triton is coming closer, so much so that it's expected to crash into Neptune in the future. At the same time, some moons like Naiad and Thalassa have a stable resonance that allows them to orbit stably while preventing them from coming too close to the planet itself. While we're on the topic, let's talk about the oldest moon of Neptune, Nereid. This irregular moon has a highly elliptical orbit and significant orbital eccentricity. Its orbit extends way past the orbit of Triton, which could mean it's also under the gravitational influence of the Kuiper belt. Triton seems to be the most interesting moon Neptune has. It's the 7th biggest moon among all the moons in our solar system and the biggest moon orbiting Neptune. But that's not the fun bit. It's the retrograde orbit of this moon. This giant moon's orbiting direction and size are unique, and the theories surrounding its recruitment as the moon of Neptune are just as interesting. Before orbiting Neptune, it is speculated that Triton was orbiting the solar system in the Kuiper belt. This sheer size of Triton is predicted to have caused significant gravitational disturbances around Neptune, jumbling the whole ring and moon web around it. Triton also features geyser-like plumes on its surface. These nitrogen gas and dark particle eruptions shoot towards space and tower over 8 kilometers above Triton's icy surface. Since the moon is responsible for tidal changes on the parent planet, these plumes may impact Neptune's subsurface oceans. Similar to plumes, cryovolcanism is another such phenomenon found on Triton. Unlike plumes, these volcanoes spew out icy water, ammonia and methane eruptions driven by internal heating. These icy volcanoes offer clues about Triton's geological activity and the dynamics of icy moons in our solar system. Did you know Neptune and its moons were named after Greek and Roman mythological creatures? If not, subscribe and hit the notification bell to keep watching exciting cosmic videos. Now, there are multiple reasons why Neptune is just not livable. One of the biggest ones is its proneness to large storm swirls. Storms coupled with its icy atmosphere and supersonic winds are just a recipe for disaster. The Voyager 2 spacecraft recorded the wind speed to be a whopping 2,000 km per hour. For comparison, the highest wind speed ever recorded on Earth is about 407 km per hour due to Tropical Cyclone Olivia. Incidentally, during the 12 years that the Voyager 2 spacecraft was orbiting Neptune, it was able to record 2 egregiously harsh storms that left behind giant spots on the planet's surface. Astronomers named these spots as the Great Dark Spot. The storm was approximately the same size as our home planet, and the spot it left behind was comparable to the red spot on Jupiter. Interestingly enough, the Hubble Space Telescope could see that the Great Dark Spot was no longer there, but there was the onset of another colossal storm. Now, do you think that since Neptune is far from the Sun and its surface composition is icy and has massive storms, it's probably a snowy planet, right? Amazingly, it also has an internal heat source. The possibility of such a heat source was concluded as part of research back in 1975, when infrared measurements were used to discover temperature inversion. In simpler terms, it was found that Neptune's atmosphere is coldest near the surface of the planet and grows warmer as you extend out towards space, exhibiting a clear contrast to the Earth, where temperature is warmest closer to the surface and coldest to space. Safe to say, no life is surviving on that ice surface. This warmth and temperature further from the surface was thought to be only due to sunlight absorption by the methane gases in the atmosphere. However, the temperature inversion numbers were too high, leading this study to conclude that there must be an internal heat source, as simple light absorption can't be the only cause. The decay of radioactive elements within its core is theorized to be the cause of the internal heating system. This process has contributed towards maintaining Neptune's internal temperature for billions of years. Let's get a little nerdy and talk about the magnetic fields. The magnetic fields of Neptune, unlike the Earth's, are dipolar. What it means is that there are no two straightforward poles on Neptune. A model-based study suggested Neptune's magnetic field exists in a skinny layer beneath the outer atmospheric layer of hydrogen and helium. Unknown interactions between this fluid layer, Neptune's interior, and supersonic water conditions may contribute to the wobbly magnetic field that somehow works to protect the planet but is not as good as Earth's structured field. This magnetic field also has a slight tilt at an angle of about 47 degrees relative to its rotational axis. For comparison, the magnetic field tilt of Earth is only about 11 degrees. Neptune's magnetic fields impacts the planet, its moon, and its ring system, contributing to radiation belts and stability. If toxic to human atmosphere, supersonic windstorms, and icy cold surfaces haven't convinced you that Neptune is strange, this will. It has shorter days than Earth, but longer years. A day on Neptune is only 16 hours, whilst a year is around 165 Earth years. Furthermore, it's the farthest away from the Sun, implying that the seasons on Neptune last a while. The amount of sunlight that each portion of Neptune gets is disproportionate, affecting both seasons and weather dynamics. Yeah, imagine staying in the same grade for 165 years. Now, let's move towards the question we've all been waiting for. How Neptune's existence was proven. So, this planet was discovered way before it was first observed, and that was via mathematics. During the 19th century, astronomers observed eccentricities in the orbit of Uranus that gravitational interactions with known planets couldn't explain. French mathematician Urbain Le Verrier and British astronomer John Couch Adams calculated the position and predicted the existence of a new planet based on these deviations. In 1846, Johann Gottfried Galle at the Berlin Observatory observed Neptune exactly where Le Verrier had predicted it would be, within 1 degree of its calculated position. This discovery confirmed Neptune's existence and validated Newtonian mechanics and gravitational theory on a grand scale. It remains a significant milestone in astronomy and planetary science history, showcasing the power of mathematical prediction in uncovering cosmic phenomena. Now, Let's rewind and recall the important points we've discussed so far. Neptune, the ice giant of our solar system, stands out with its deep blue colour and intense weather, its atmospheres containing icy methane, creating winds faster than any on Earth. Voyager 2 revealed many of Neptune's secrets, including the Great Dark Spot and ring arcs shaped by the moon Galatea's gravity. Triton, Neptune's largest moon, has nitrogen geysers and icy volcanoes. While moons like Hippocamp drift away, Triton moves closer to Neptune, leading to a future collision. Neptune's magnetic field is unusual and affects its moon and rings. With shorter days and longer years, Neptune remains a planet full of wonders. So there you have it, guys. The mysteries don't end at the doors of Neptune. There's much more to explore in the cosmic world. While some facts are horrible, others seem surprising. What do you think about Neptune? Something friendly or like a monster? Share your thoughts in the comments below.